Good morning, students. Is my screen is visible? Am I audible?
Yes, sir.
Yes. Thank you. So, good morning, students. So, I welcome the class number module 14, right? The class module 14 in the IC engine subjects in the unit of the petrol engine, right? So, today we are going to discuss about the gasoline injections and the types of the gasoline injection systems, right? So, first of all, we have to know why we are using the carburetors, right? Why we are using the carburetor, right? So for the petrol engines, the carburization process is very important one, right? Why? Because we have to mix fuel and the air. The mixture of air and fuel is the working substance for then petrol engine, right? So we have to mix the working substance, that is the air and fuel, in a correct manner, right? So we have a device for the carburization process, right? So in the carburetor, we have a different type of carburetors are there. That is the updraft, side draft, and the downdraft carburetors are there. And we discussed about what is the simple carburetor and how it can, how it's working, right? The working principle we have seen, and that simple carburetor have some drawbacks, right? So it is used for in a small type of engines. So we are not used for the large capacity engines, right? Then the air fuel mixture, the requirement, right? The engine requirement is in different conditions. It may vary, right? So the variation is required in the fuel mixture ratio, and the variation is required depending upon the engine condition. Depending upon the engine condition, we need a different type of fuel and air ratio, right? So for that we have added some modifications, right? We have done some modification in the simple carburetor, right? That carburetor is called the complete carburetor, or a modern a carburetor. That is called a complete carburetor or modern carburetor, right? So in that system we have plenty of devices, right? So majorly the main metering device, that is the combustion jet, then the auxiliary port valve and carburetor valves, right? Then the air bleed valves, right? That are all the category of the main metering system, and the idling system and the choke, right? So these terms will be added to improve the performance of the carburetor for the modern engines, right? That is the high speed engines as well as the low speed engines, right? So last class we discussed about these terms, right? So in this class we discuss how we can inject the fuel, how we can inject the fuel into the cylinder, and what are the terms will be there while injecting the air fuel mixture in the cylinder, that we can see. So in the carburetor engines, right? In the carburetor engines, the uniformity of the mixture, the uniformity of the air fuel mixture strength is very difficult to realize in the each cylinder of the multi-cylinder engines, right? So if it is in a single cylinder engine, the carburetor supplies the air fuel mixture in a inlet manifold, right? So the air fuel mixture amount will be directly goes to the engine cylinder. If in the case of the multi-cylinder, if in the case of the multi-cylinder, the air fuel mixture ratio is going to the cylinder. Each cylinder, it may get different values, it may get the different amounts, right? So it is very difficult in a multi cylinder process, right? So here you can see the pattern of the mixture distribution, in the multi cylinder engine using the carburetor, right? Using the carburetor, right? So the from the carburetor, right? So from the carburetor, the air fuel mixture comes in this direction, right? So here we mentioning the air fuel, that is air gasoline mixture, right? The air gasoline mixture will comes to this direction. So here we have a cylinder 1, cylinder 2, cylinder 3, right? So depending upon the firing order, the cylinder works, right? So either first cylinder have to work first, or second cylinder, or third cylinder, or the n number of cylinders, right? So depending upon the firing order, the cylinder will works, right? So here you can see now, here we have a three type of cylinders, right? One, two, three, right? So which cylinder is working here? Here now it's working the cylinder number 2, right? The cylinder number 2 is working. So the air fuel mixture will gets into the cylinder number 2, right? The air fuel mixture gets into the cylinder number 2, but the air fuel flow will be goes at the end of this manifold, right? So it will be reaches at the end of the manifold, right? So it reaches at the end of the manifold also, right? So at the end of the manifold you can see there is an accumulation, there is an accumulation. So in this accumulation, what will happen, the fuel amount will be somewhat high while comparing to the air. So here we can get a rich mixture, here we can get a rich mixture. That rich mixture enters into the cylinder 1 while the firing order comes to the cylinder 1 position. So automatically what will happen? The intake valve open here, then the air fuel mixture will be sucked into the cylinder number 1. So there we can get a rich mixture, right? There we can get a rich mixture, right? So when the cylinder is nearby the carburetor, when the cylinder is nearby the carburetor, it will get automatically a lean mixture. When the cylinder is away from the carburetor, we can get a rich mixture. So we have a different type of mixtures in the each cylinder, right? It's very difficult one, right? It is very difficult one. So this type of the distribution, this type of the distribution is called the Mal distribution, right? So this type of distribution is called Mal distribution. So the various cylinders receives the various amount of the mixture in varying quantities and the richness also, right? So this type of distribution is called Mal distribution, right? So this type of Mal distribution is not good for an engine, right? Not good for an engine. So we have to avoid that Mal distribution. We have to avoid the Mal distribution, right? So how we can avoid? So we have to develop the carburization system, that is the injection system, right? So we introduce some injection system, right? So the injection will be like that, then only we can get a efficient engine, right? So we are developed, right? We are developed a different type of injection systems. We developed the different type of the injection system. That injection system is called the gasoline injection system. And here also we have some types, right? Then, right, so why we have to introduce a gasoline injection system, right? So then why we have to prefer, right? So instead of the carburization, that is the carburetor, right? Instead of the carburetor, we are introducing the gasoline injection system, right? So why means the first condition, we have to supply the distribution of the air fuel ratio in all cylinders, right? It is especially for a multi-cylinder, right? So in the all the cylinder we have to supply the same amount of air and fuel ratio, right? So then only we can avoid the mal distribution. So we have to prefer the gasoline injection system, right? So first we have to distribute the uniform amount of the air fuel ratio, right? We have to distribute the uniform amount of the air fuel ratio in a multi-cylinder engine. And we have to increase, we have to develop, we have to improve the volumetric efficiency, that is the breathing capacity, right? The breathing capacity, right? That is the volumetric efficiency. And we have to reduce, or we have to eliminate the detonations, right? So when the detonation comes means the irregular mixtures, the irregular mixtures goes into a different type of cylinders. So due to that distribution, right? So there the detonation will be occurs. There the detonation will be occurs. So we have to reduce and we have to eliminate the detonations, right? Then we have to prevent the fuel. We have to prevent the fuel loss in the process of the scavenging, in particularly two-stroke engines, right? So what is the scavenging? The removal of the exhaust gases. The removal of exhaust gases from the two-stroke engine is called a scavenging, right? So during scavenging, some amount of the fuel mixture also goes out, right? So we have to prevent that fuel loss. We have to prevent the fuel loss, right? So for that also we are using that this for that also we are preferring the gasoline injection system, right? Then here we have a different type of gasoline injection systems, right? That we can see. So the first one is the gasoline is injected by direct injection. That is the gasoline direct injection into the cylinder, right? The gasoline direct injected to the cylinder. It is the first one, right? Then the second one is the port injection, and third one is the manifold injection. Then third one is the manifold injection, right? So in that port injection, we have two injections, right? So in the port injection, we have two injections. That is, one is the timed port injection, and the second one is the continuous port injection, right? So one is the timed port injection, and second one is the continuous timed injection, right? So now we can see one by one, right? Right. So these are the fuel injection methods. These are the fuel injection methods, right? So before seeing this one, just listen what I am saying, right? The types of injections. So these, right? So these types of injections can be grouped, right? Can be grouped under the two categories. So one is the single point injection, and another one is the multi-point injection, right? So whatever it may be, right? So the direct injection or a port injection or the manifold injection, right? So whatever may be the type of injection, they may be uh, grouped in the two categories, right? One is the single point injection, and some more is the multi-point injection, right? So in a single point injection system, we have only one injection or a two injection, that is, right? So only one injector or a two injectors are mounted inside the throttle body assembly, right? See here. All right. See here or here, right? So here we have a two type of injections, right? So one is the direct injection and one more is the manifold injection, right? That is, one is the port injection or a manifold injection, right? So here we can see the types of injection, right? One is the direct injection, one is the direct injection, and second one is the port injection, and third one is the manifold injection. So here you can see it is the direct injection, right? It is the direct injection. So the fuel injector, right? So this fuel injector injects the fuel directly to the engine cylinder, right? So this type of injection is called the direct injection of the gasoline, right? Then the second one, here see, the injector injects the fuel. The injector injects the fuel at the inlet manifold, right? It is called the inlet manifold, right? So the fuel will be injected through the manifold. Then the fuel will be passed through the cylinder, right? So this type of injection is called manifold injection. This type of injection is called manifold injection. And here you can see So it is not a manifold and it is not a direct injection, right? So it is a semi-direct injection. It is called a semi-direct injection, right? So here we can see the three type of injection methods, right? Here we can see the three type of injection methods, right? So uh, for the group of the single point and the multi-point injection system, right? So in the single point injection system, we are using only one or two injectors which is mounted inside the throttle body assembly, right? It is called the throttle body assembly. Then the fuel sprays are directly at the one point or a center of the inlet manifold, right? So see here, the fuel sprays directly to the engine cylinder or a center of the manifold or a center of a manifold. Is it clear? Say the fuel sprays directly at one point or at the center of the intake manifold, right? So then the second one, that is the multi-point injection system. We are using n number of injectors, that is multiple cylinders. Then how many cylinders we are using? The same amount, right? The same number of n we are using the fuel injector. So each cylinder we having a single injector, right? Single injector that injects the fuel to the directly to the cylinder, or it may be using for a throttle body cylinder, right? So that is called the direct injection of the gasoline into the cylinder. Then the second one is the port, right? So most of the gasoline fuel injection system, the gasoline fuel injection systems used in the SI engines are two type of injection. One is the continuous injection and one more is the timed injections, right? So for the continuous injection systems, uh, for the continuous injection process, the rotary pump which is used, right? The rotary pump which is used to the fuel, pump the fuel from the tank to the engine cylinder at the pressure of 0.75 to 1.5 bar, right? So the pressure, right? The rotary pump will be used to pump the fuel and to supply, pump the fuel from the tank and to the inlet manifold or a cylinder at the pressure of 0.75 to 1.5 bar, right? So in this system, and the fuel through the nozzle is located the manifold immediately the downstream of the throttle plate. Then the supercharged engines, right? In the supercharged engines, the fuel is injected at the entrance of the supercharger, right? So what are the superchargers? That and all we can see in the latter units, right? Then the timing and the duration of the fuel injection is determined by the ECU, right? The nowadays we are using most of the injection system will be in the electronic injection system, right? So here we are using the ECU, that is the electronic control unit, right? So the electronic controlling unit will control the fuel flow, right? The electronic control unit will control the fuel's flow depending upon the load and depending upon the speed condition, right? So the various load and various speed condition, the the speed and load conditions will be identified by the sensors. That sensor will gives the information to the electronic control unit. That electronic control unit controls the fuel injector, right? So that controlled fuel injector will sprays the amount of the fuel will be in controlled manner, right? Then the timed fuel injector system, the fuel supply pump which sends the fuel at the low pressure, it's about 2 bar, right? So when the engine is running at higher speed, that is the maximum speed, the engine is running at maximum speed, the fuel supplies in a low pressure, that is the 2 bar pressure, right? Then the fuel is metering or a injection pump and a nozzle are the part of the injection systems. The parts of the injection system. The nozzle injects the fuel in the manifold of the cylinder head. Right, manifold of the cylinder is about 6.5 bar pressure. 6.5 bar pressure. Right. So these are the methods. Right. These are the methods, and these are the types of the gasoline injection system will be used in the modern or newly developed engines. Then the components of the injection system. Components of the injection system, right? So the objective of the injection system is to meter, to atomize, and the uniformly distribute the fuel throughout the air mass engine cylinder, right? So what is the meter? The amount, right? So we have to control the amount, right? That system is called the metering of the fuel. That system is called metering of the fuel, right? Then what is the atomize, right? Atomization means the fuel particles mixed with the air, right? That process is called the atomization. In the carbonization process, what will happen? The air and the fuel will be mixed together, right? So here the atomization also the same, right? So it will mix the air and the fuel particles, air and the fuel particles. That is called as the atomization, right? So here you can see the components, right? So first of all, we have to pump the fuel from the fuel tank to the engine cylinder, right? So we are using the pumping element, right? Then the metering element, right? So here the metering element, what will happen? We have to see the how much amount of the fuel, how much amount of the fuel particles will be enters into the cylinder, right? So uh, that will be sensed by the metering element. And the mixing element, that is the atomization, right? So the atomization is the process to mix the air and the fuel particles, right? So that will be in the mixing element. And we have metering control. See these two, right? So here the element is to identified, or it may be a mixing one, that we have to control these two, right? So we have to control the amount of fuel entered to the cylinder and the air fuel ratio control, right? So these two, right? And the distribution, that is the nozzle, right? Distributing elements, right? So in the injection system we have six, right? We have six components, right? So that is the pumping element, metering element, mixing element, metering control, mixture control, and the distributing element, right? So here we can see the function of one by one, right? So the pumping element, right? So what is the function of the pumping element, right? So we have to move the fuel from the tank to the fuel injector, right? So the necessarily we have a pump, right? So the pump will be pumps the fuel from the fuel tank to the engine cylinders injector, right? So between the pump, between the tank and the injector, we have different pipings, right? And the fittings are there, right? So including the pipings and the fittings, right? And the pump, fuel tank, and the injector, right? So this element is called the pumping element, right? This element is called pumping element. And the second one is the metering element, right? So we have to measure and the supplies the fuel at the rate demanded by the engine at various conditions, right? Depending upon the load and the speed conditions, the engine required the different amount of the air fuel ratio, right? The different amount of the air fuel ratio. So the measures and supplies of the different type of the air fuel ratio by using the metering element, right? Then the third one is the mixing element, that is the atomize the, that is a mixture of air and fuel. That is process is called the atomization process, right? It atomizes the fuel and the air mixture in the form of the homogeneous mixture, right? It forms a homogeneous mixture, that is the mixing element, right? And the fourth one is the metering control, right? We have to adjust, right? We have to regulate, right? We have to regulate or adjust the air fuel ratio, depending upon the various working condition of the engine, that is the different speeds and the different loads, right? So depending upon these engine conditions, we have to regulate the air fuel ratio supplies into the cylinder, right? So that system is called the metering control, right? Then the mixing control, right? So for the same, the different engine conditions, that is the different speeds and the different loads, will require the different amount of the fuel ratio, different amount of the fuel, and the air supplies the ratio, right? So that ratio will be controlled by the atomization process, right? So that unit is called the mixture control unit. And the distribution element, right? So we have to divide the amount of the fuel into the each cylinder, right? Each cylinder we have to divide the amount of fuel supplies, right? So the we are using the different nozzle systems, right? That nozzle system is called the distributing element, right? Then, so these are the components, right? These are the components which is used in the injection system, right? Is it clear? Is it clear?
Yes, sir.
Just wait. Is my screen is visible?
Yes, sir. No problem.
So the next topic is the electronic fuel injection system. Right. So the next topic is electronic fuel injection system. Right. So in the modern cylinders, in the modern engines, right? So the most of the engines work with the help of the sensors, right? Most of the engines will be worked with the help of the sensors and computers and a solenoid operated solenoid operated injection systems for the different controls, that is the metering, right? That is metering and the atomization and for the distribution element, right? So the different, see, each element will have a sensing element, right? So each component will have a sensing element, right? So these sensing elements are incorporated with a computer or a microprocessor. That system is called the electronic fuel injection system. That system is called electronic fuel injection system, right? So this electronic fuel injection system will be uh, classified or will be incorporated with the two major terms, right? So one is the monitoring system and one more is the control system, right? So electronic control system and the electronic sensors, right? The sensors will be a monitoring one and the control unit will be a regulating one, right? So one is for monitoring and one is for the regulating or a control, right? So in the electronic fuel injection systems, right? So most of the engine components will be sensed, and why we have to sense means we have to control the properties, or we have to control the elements which will inside the cylinders, right? So the electronic fuel injection systems will be incorporated with the metering elements, that is monitoring element and the control element, right? So these two elements is mandatory for the electronic fuel injection system, right? Then we can see first what is the monitoring system, what is the monitoring system, and second we can see what is a control system, right? So for the monitoring system we are using the plenty of the sensors, right? We are using the many sensors for uh, for monitoring the fuel injection systems, right? For monitoring the fuel injection system. So here we can see the exhaust gas or the oxygen sensor, and the engine temperature sensor, airflow sensor, then inlet air temperature sensor, the throttle position sensor, manifold pressure sensors, and the camshaft sensors, right? So now we can see the one by one, right? So in the exhaust gas, right? So first we can see the exhaust gas or oxygen sensor, right? So here it sends the amount of the oxygen in the engine exhaust, right? The amount of oxygen in the engine exhaust, and it calculates the air fuel ratio, and it calculates the air fuel ratio, right? The exhaust gas or the oxygen sensor, right? So while in the burning of the air fuel ratio, air fuel mixture burning in the engine cylinder, then in the exhaust condition, how much in the exhaust gas, how much of oxygen content will be there, right? That we have to sense, and the amount of the air fuel ratio, and we have to calculate the amount of the air fuel ratio, right? So in the sensor output, the voltage changes, right? Here the voltage change, output voltage changes in proportion to the air fuel ratio, right? So in this exhaust gas or the oxygen sensor, right, the output voltage changes in proportion to the air fuel ratio, right? Then the second one is the engine temperature sensor. Engine temperature sensor, it sends the temperature of the engine, right? It sends the temperature of the engine, as well as the engine coolant, as well as the engine coolant, and it forms the data, right? And it forms the data. The computer adjusts the mixture of the strength, that is the either the engine speed is high, the engine speed sorry, engine temperature is high or a low, right, which is sensed by this sensor, or the engine temperature, the coolant will be high or a low, right? So depending upon this engine temperature, right, depending upon the this engine temperature, the system, right, the system will adjust the mixture of the air fuel ratio, the supplies the air fuel ratio, whether we have to supply a lean mixture or whether we have to supply a rich mixture, right? So depending upon the engine temperature, right, depending upon the engine temperature, the it controls and it supplies the air fuel ratio, it's strengthening, right? So it changes the strength of the air fuel ratio, right? Next one is the air flow ratio. Next one is the airflow ratio, right? So it monitors the mass or the volume of the air, right? Volume of the air is flowing into the inlet intake manifold, right? So how much amount of air is supplied in the intake manifold, and then how much amount of mass or how much amount of volume of air is flowing through the intake manifold for the adjusting the quantity of the fuel, right? Then the third one, sorry, fourth one is the air inlet temperature sensor, right? So it checks the temperature for the ambient air, that is the atmospheric air enters into the engine for the fine tuning of the mixture strength, right? For fine tuning of the mixture strength. And the throttle position sensor, right? It sends the movement of the throttle plate, that is the accelerator plate, right? So throttle plate, so that the mixture flow, the mixture flow can be adjusted, right? The mixture flow can be adjusted for the engine speed and the acceleration, right? That is called the throttle position sensor. Then the manifold pressure sensor, manifold pressure sensor, right? So in that manifold pressure sensor, it monitors the vacuum in the engine, right? It monitors the vacuum in the engine intake manifold. So the mixture strength, the air fuel mixture strength can be adjusted when the changes in the engine speed and the load condition, right? When the engine speed and the load condition. Then the second camshaft position. Camshaft position sensor sends the rotation of the engine crankshaft or a camshaft, right? Crankshaft and the camshaft of the speed and the timing of the injection, right? Then apart from these sensor, we have one more sensor, that is a knock sensor, which is here I didn't mention that one, right? Unfortunately, I didn't mention. So that also you can note, that is the knock sensor, right? So it is the microphone type of sensor that detects the ping or the pre-ignitions, right? Pre-ignition noise, so that the ignition time can be reduced, right? So that type of sensor is called the knock sensor, right? That type of sensor is called the knock sensor, right? So these are the sensors which is used in the electronic fuel injection system, right? And uh, we have the purpose, right? Why we have to use the multi-point fuel injection systems, right? Why we have to use the multi-point fuel injection system, right? So the purpose of the fuel injection, that is a multi-point fuel injection system, is to supply the proper ratio of the mixture, the proper ratio of the air and the fuel into the cylinder, right? So the multi-point system, that multi-point system can be have two basic arrangements, can be have two basic arrangements. So one is the port injection, and second one is the throttle body injection, right? Then the throttle body injection, right? So in this diagram you can see it is the port injection, it is the port injection. It is a port injection means uh, the injector is placed on the side of the intake manifold or nearer to the intake port, right? So the injector is placed, right? See, it is the injector. The injector is placed near the inlet manifold or intake port, that is intake opening, right? So the injector is placed on the side of the intake manifold, it's nearer to the intake opening, right? Intake opening. So the injector sprays the air fuel ratio, air fuel mixture inside the cylinder, right? So the air fuel mixture, air fuel mixture is reasonably uniform manner. It's used, it is in the uniform manner. Right? Is it clear? Right. So for the multi-cylinder, right? It is for a single cylinder port injection system, right? It is for the single cylinder port system, right? And for the multi-cylinder means, so the injectors, see, the injector is placed in each cylinder. The injector is placed each cylinder nearby the inlet opening, of the cylinder, right? So here you can see the that multiple injectors will be used for the multi-cylinder engines, right? So which is located in the inlet manifold, and very nearer to the inlet opening, right? So this type of system, this type of injection is called a port injection. This type of injection is called a port injection, right? Then the second one is the throttle body injection, right? So here we are using a single injector, right? So here we are using the single injector. It injects the fuel air and it supplies the fuel air to the multi cylinder, right? So it will supply the multi cylinder, right? The single injector injects the air fuel ratio to the multi cylinder, right? So this type of injection is called a throttle body injection, right? This type of injection is called a throttle body injection, right? So either the port injection or a throttle body injection the system it works, right? Maybe in the pulse system, right? So when the fuel has to be injected, right, it is in the form of the pulse system or a continuous system, right? So the both systems, the amount of the fuel and the air is injected depending upon the engine speed and the power demands, that is the engine requirement, right? So we have two types of the multi-point injection systems, right? We have two types of the injection system, that is multi-point injection system. One is D multi-point fuel injection system, and one more is L multi-point fuel injection system. So that we can see in the next class.